Four identical springs are arranged as shown and suspended from a support. A load of weight 8.4 newtons is attached to the hook at the lower end of the springs, and this causes a total extension of the system of 24 millimeters. The arrangement is then changed to this as shown. The load of 8.4 newtons is attached to the bottom of the lower spring. What is the total extension of the system at equilibrium in the second arrangement? So the first thing to realise is that we don't really need to care about the 8.4 newtons here because it's kept fixed in both. What we really need to see is how the spring constant or effective spring constant or stiffness has changed between the two systems. So we could ignore the 8.4 newtons for now and then just look at how the stiffness has changed. In the top scenario, we have these springs attached in series in each section and then added in parallel. So we've got K over 2 plus K over 2 equals K. And I know it's K over 2 for the adding springs in series because whenever you do it, you'll do a 1 over K plus 1 over K is 2 over K. You'll flip it, you get K over 2. So that's just something you should commit to memory whenever you're adding springs in series. So if I had 3 in series, I'd get K over 3, 4 in series, K over 4, and so on. Now let's look at the second system. We have the 3 springs in parallel. So this will give us a 3K. But then this is in series with a K. So we'll need a 1 over 3K plus a 1 over K. This gives us a 4 over 3K. And what I'm going to do is I'm not going to flip it for this. I'm going to flip the other one. I'm going to write this as 1 over K. Because we know our extension is equal to force divided by the effective spring constant. So from this, we just need to see how does the extension change compared from one to the other. So the second one is going to give us 4 over 3 times the extension of the top. So 4 over 3 times 24 millimeters. Because I can see here it's got a 4 over 3 in front of the 1 over K. And we know that the extension is F over K, as mentioned earlier. So 4 over 3 times 24, so 24 over 3 is 8. 8 times 4 is 32 millimeters. So we get the answer of E for this extension. Another thing to note is that if you've done resistors in parallel often, then when you're doing springs in series, you should get a similar form to what I've said before. So whenever you've got something like 2 systems in series, we get 1 over K1 plus 1 over K2 equals 1 over K effective. This gives us K effective is K1, K2, K1 plus K2. This is equal to the product over the sum. So if I wanted to get the effective spring constant, I'd just do product of the spring constants over the sum of the spring constants when I'm adding them in series, equivalent to when I'm doing resistors in parallel. So it's something to bear in mind just so you can quickly remember how to do it rather than having to go through this calculation every single time. Hopefully the solution made sense, but if you have any questions, please do let me know in the comments.